Hey guys, this is Jerry here. It's been a long wait and I'm finally back with a banger. And in this video, I'll be recording you and taking you through the process of creating GCP buckets and using Vertex AI to actually make an end-to-end ML pipeline. So stay tuned and here the video begins. We need to demonstrate the Iris classifier pipeline on the Google Cloud. So the goal is to use a single GCS bucket, which I've done along, and I have created the manual data and artifact folders within which uh, the folders of that update train data will be deployed during the runtime. And I also ran it on the two versions of the datasets that we were given, version 1 and version 2 of the Iris dataset. So I've done it through two process, which is I felt that the first one would be our traditional workbench model using Vertex AI. So which is the goal of this assignment. So initially I've just created the instance details as directed in the I've created the environments and also set up the hardware properly appropriately according to us, and also the disk type, which is the least cost one, so that it consumes less RAM and software and CPU and disk size. And instantiated this and opened the Jupyter lab. And after that we have the reference notebook. So I'm running my code over here. So the location and the project ID will be different since it's unique for each of us, and the project ID can be found over here. So which is the my project, my first project, and within this we can see the project ID over here. So we just need to grab it from there and paste it over here, and we are done with that. And we need to create the bucket by going to the Google storage. Cloud storage is over here, and in this cloud storage, I've created two separate files. So, but we need the bucket ID. So we have the bucket ID over here. So, and then we'll just grab it and paste it over here. And this is our model file where our job file will be dumped. So this is where it is. And after that, we just need to run this AI platform so that it uses the Vertex AI API so that we will be able to run this. And by linking it with our bucket URI in which our dataset is present. So to the goal of this is to actually get the data from the data safety. So here I faced an error, that is the permissions were not enabled. So it is simple. All you need to go back to your cloud storage, go to the buckets, go to the permissions tab, and then uh, go over here and click on grant access. So after you do that, you're getting this, and in this principles, you just need to copy the ID from here and then paste it over here. So that's how it is, and then you can just settle which I gave it as a storage admin so that we can have all the possible permissions given. So that's how it is. Just cancel it out, and then so this is the our classical ML approach. We just need to define the test data set. I just took it as 40% as test set, 60% as a training data set. The random state is a seed, so that the training test split won't split it anymore differently, and the training will be done according to the saved model within the 42 size. So next, we'll just run it, and this is the model underscore DT. DT stands for decision tree over here, which I'm using. And to keep things simple, just took it as a max depth as 3, the random state one, so that the way the model gets trained will be constant and it won't change. So we got a score of 0.95. So the crux over here is we can't directly add this uh, to our Google bucket, GCS bucket storage, Google Cloud storage bucket. So we need to save it initially as a local model path, which I've done over here. And you can see in the artifacts folder is the model.joblib. So now we have this Google Cloud import storage. So now the project ID, which we can access it through this as well, rather than copying it over there. So there are two approaches which I showed you right now, which is going over here, going to my project and grabbing the ID, or you can using to the CLI approach, which is was.environ.get using this. And this is the name of my bucket. So I've named it according to the good practices, which is the project ID and my uh, ML and the week one pertaining to it. So now the client is the so now the client will be called storage.client. So this is the call we need to write to actually access the project ID pertaining to a particular client. And now um, we have also initialized the bucket pertaining to a particular client, which is us. And now we will be uploading this. This is binary object file. So we'll be uploading this as a blob file to the bucket, and then we'll be uploading it. So rerun it. So you can see there's no error this time. And now since there is no need for pre-processing, since it is a perfectly pre-processed file, there won't be any pickle file for pre-processing. But in case we want to deploy this model on any other platform, we need to add the pre-processing pickle file as well. So now we'll just go back over here and I'll be showing you the object, load objects. So here you can see that the classifier has been created along with the model, and this model, we have the model.joblib. So and this is a public URL in case we want to use this model to train other data set. So this is the now I would like to show you the thing that I did it by my an alternate method. So it is by committing it from the Cloud Shell itself. So I cloned my GitHub URL in initially, and then use that standard git checkout week one and the traditional commands. And now this is the folder path that I've chosen: artifacts, data. So these are the part. So these will be created during the runtime, and these will go to the get ignored folders. So now the running mechanism, the code is same over here. So the thing is, this is an additional path since we are not using Vertex over here. This is an alternative of a Vertex. So, so we are defining the functions to be downloaded from the Google Cloud Storage. So after we download this particular, after we follow this code, and is also to upload it to that. And now in the main function, we'll be running if there are two versions in the week one that we have been given. So in case if the data version is week V1, the data will be stored in this GCS as IDS1 and it will be saved over there. And the rest is the same, dividing it into the train and test splits. And the code is the classical ML participant. So now the timestamp here it comes. So this is the formatting that I chose over here, and it will be the part that I showed you in the Vertex AI is saving it to the local and then uploading it back to the Google Cloud Storage. Uh, so over here we have the joblib.run. So CLF is our classifier name, and the model path which specifies the classifier. And we'll be storing the accuracy in the text file called so metrics.txt. And now we will be saving this sending this back under the artifacts folder and uploading it back to the uh, Google Cloud Storage. So now this is argparse.argument parser. So what this does is, while we are running a file, we can have multiple arguments parallelly. So the argument is of the format. So this is the deep. So this is the comment that I will write, and then I'll be choosing among these two. And by default, if I don't have any, it will be considered as the version one dataset. So let's just get into it. I'll write a simple script, we predefined one. So here the shell script or the bash script shows that I'll be running the Python program over here, and I'll be storing this in the particular variable ts1. So over here, after we run this particular code, uh, we will be getting it as or we could just run it normally without any of this. So this is just for us understanding. So if we run it normally, oh, so, so now let's get so after this, uh, there might have been an issue within this. This is an error from the Google Cloud. So if we run it normally, we can see this that the proper data is actually the it actually got called Redis underscore version 1. So in the artifacts as well, uh, it's using this data, and now the thing is we have and also in the artifact files we'll be getting the particular data as well. So after running this, we'll just need to run the same but with the timestamp. So just show it can be done. So timestamp and with a particular product item to the format be 2026 the year would be first and next the date and the time and then followed by the hours and the minutes. So this is how we will be running the inference file. So after running that, we'll be getting the scores and the accuracies. So if we this is this is how we can actually implement it through the Vertex and architecture cloud shell.